In the last class, we discussed regarding a key management. In this key management section, we discussed regarding the way in which a public key will going to be distributed. There we discussed regarding a distribution of a key with the help of X.509 certificate through which the public key was distributed. And the major role played in distribution of those keys is by a certifying authority, CAs. The CA certifying authority is the one who issues these certificates. Now we're going to discuss regarding public key infrastructure. The CAs are part of these public key infrastructures. So apart from CAs, these PKIs, these public key infrastructures, also includes a hardware which is needed to create the certificate, to maintain these certificates, and apart from that, it also has a software which performs a job of encryption. So in short, I can say PKI includes the PKI is made up of CAs, encryption technologies, hardware, and other things that are related to a distribution of these keys. These PKIs also includes the entire thing that is needed for providing the services in support of use of digital certificates. Some of those functions we have listed over here. So its job is to create the certificate, issuing of certificate, storing of these certificates, and providing an archival of these certificates. Apart from that, its job is to generate the keys and cancellation of keys. One more important job of this PKI is to issue a certificate, update those certificates. Apart from that, it also performs the job of updation of keys. And in case something goes wrong, it also performs the job of certificate revocation. Out of these, the major important function of the PKI is to provide a safe archival facility for all issued certificates. There are crucial differences in support required for private keys compared to that of public keys. In case of encryption and decryption, it is often necessary to have a backup of decryption key. It is mainly because if employee loses his decryption key, then it is difficult or it is impossible for an organization to decrypt the archives of sensitive data that may be stored in the organization. For this reason, the public key infrastructure within an organization, for example, might hold the private keys in safe. That is, it may be securely backed up and made available to the owner or the trusted authority under the special circumstances. On the other hand, there is no need to back up a private key used for signing. If such a key is lost, the owner could inform certifying authorities or public key infrastructure administrator. He or she could obtain a fresh signing key and receive a new certificate carrying corresponding public key. Given the situation of private key is used for signing, an individual should have his signing key backed up by anyone else, An important function of PKI is to provide safe archival facility for all issued certificates. Consider the situation where a signature on a will needs to be verified several years after will was made. It is possible that signer has misplaced his or her certificate, that the signer is now say dead, say, or otherwise you can say no more. In these cases, the archival facility of PKI will be of a great help. We discussed regarding the functions of PKI. Now we'll talk regarding the PKI architecture. When we talk regarding the PKI architecture, the most important entity of this PKI architecture is certifying authority. The certifying authority is the one who is responsible for issuing of certificates to the users, and using those certificates the users in turn communicate with each other in a secured manner. So this type of an architecture where a single certifying authority is involved, that we call it as single CA architecture. So in this case, one CA is issuing certificates to all its users. Now imagine a situation where tens of millions of users who may need a certificates. It is not practically possible for a single CA to issue certificates to all of them, and it is the one that requires much background checking. Apart from this, a single CA architecture is not a scalable type of architecture where, say, as number of users grows, then single CA architecture will fail drastically. The practical solutions for this type of a problem is, say, scalability and say maintaining of these certificates and handling a large number of users, is that say we go for a different architecture. So this type of a thing, say, forces us to have an architecture in which there will be a multiple CAs involved. This type of a architecture we call it as hierarchical architecture, where we can imagine a situation of multiple CAs, but this particular situation is handled by a main CA who in turn will going to appoint some CAs for whom he is giving a certifying authority. These CAs in turn, they will create, say, some more CAs under them, and through which they will issue certificates to different users. This type of architecture will help us to handle the situation of scalability. The major advantage of this hierarchical PKI architecture is that we will going to it helps us to solve the problem of scalability. But consider a situation where, say, U1, say user 1, U1 here indicates user 1, needs a public key of, we'll talk regarding U5. Fine. So U5 certificate in this case is signed by CA6. The user 1 who belongs to CA2 may not have a CA6 public key. He does not have his public key to verify the certificate of U5. Maybe he get a certificate of U5, but it is issued by CA6 and he does not have anything to verify the thing that is certified by CA6. So to verify the U5 certificate, he must have, say, a public key of CA6 for its verification. So he must know the certificate, he must know he must know regarding the C6, certifying authority 6. But in this case, there is no way that he knows regarding a CA6. So to make these two people to communicate in a secured fashion and to provide a means for U1 to verify the certificate of U5 that is issued by CA6, we need, say, some chain of certificates for that purpose. So those chain of certificates are the certificate signed by CA1, say which is for CA3, which is vouching CA3. Then the certificate signed by CA3 vouching for CA6 public key. Then the certificate signed by CA6 vouching U5's public key. So these chain of certificates, we need three certificates. First one is the certificate that is signed by CA1 for CA3. The certificate that is signed of CA6 certificate is signed by CA3. Then the certificate of E5 which is signed by CA6. All these chain of certificates we need to provide a proper way of verification of U5 certificate by U1. And this chain of certificate issuance is possible only if all these users know regarding its root. All this was mainly because that these second and third level CAs, they does not have a direct communication between them. You see in this architecture, so all of them, they are, say, connected to CA1. So that means all their communication happens through CA1. So this is what is a major drawback with this hierarchical tree architecture. Now to eliminate that particular drawback of, say, chain of certificates, say, the one more architecture was introduced, that is mesh based PKI architecture, in which, say, these CAs have, say, interconnecting paths through which they can communicate. This architecture is based on mutual trusting of these certifying authorities. CA1 is trusting CA2 and CA2 is trusting CA4 as well as CA3. So, and again in turn CA2 is also trusting CA1. So these bidirectional arrows are indicating the trust between them. So that means CA1 is also trusting CA3, CA3 is also trusting CA1, because of which because of this trusted links between CAs, which helps users in turn to verify the certificates of the other users who belongs to a different CAs. The one more bigger advantage of this mesh based PKI is that, say because of these multiple paths between a CAs provide a greater resilience in the event when one or more these certifying authorities being compromised. One more important, say, PKI architecture is bridge based PKI. So in which, say, whenever an organization has its own PKI, so to communicate with the users of another organization which is again, say, maintaining its own PKI, in such situation this architecture, bridge based architecture, will going to be very useful. So here the bridged CA, the bridged certifying authority, is the one which is helping to create a trust between these representative CAs. So inside these organizations may have any one of these, say, PKIs. It may be a hierarchical PKI, it may be a mesh based PKI, it may be a single CA PKI, depending on the number of users in that organizations. So in case if it is a hierarchical, say, PKI architecture, in that case this CA will going to be a root CA. This representative CA is a root CA, which is in turn going to establish a trust with the bridge CA, which is helping it to establish a trust with the CAs of another organizations, which we call them as a representative CAs. So these are the representative CAs of these PKIs, and in turn they are establishing a relationship between, or trusted relationship between them through a bridged CA. So these are the four different PKI architectures which will be commonly used for, say, distribution of certificates and managing these certificates. Next, we'll discuss regarding certificate revocation. The validity period of an X.509 certificate is always contained in the certificate. For how much period this certificate is valid, that is already mentioned in the X.509 certificate. However, there are the reasons why seemingly valid certificate may actually be invalid. So the first one is the certificate may be invalid despite of being within the limits of expiry date in some conditions, is when a person loses his authorization to use the key, but still he uses it. He has left the job, but still he is using it. And when a private key, the second situation is when the private key is compromised at some level. So these are the two different situations where a certificate revocation happens before expiry date. So to understand regarding these things, we'll talk about two different scenarios. We'll consider two different scenarios and we'll discuss regarding these two revocations. Consider a scenario 1 of some company X. So on behalf of this company, the certificate is issued to a Prashant, who is an employee of that organization. Here, for understanding reason, we are considering this name Prashant. So the Prashant is the one who has details of a key with him on behalf of his company, so whose validity period is from Jan 1st 2019 to 31st December 2020. So that means the certificate is valid for 2 years. In case this Prashant, if he quits organization on 1st April 2019, if this is the situation, and again we'll do one more assumption that Prashant's certificate is used for a key exchange and authentication, and he has made the copy of it. The session key itself is then used to encrypt all the messages in both the directions for the duration of the remaining session. If this is a situation, so generally speaking, it is not legal for Prashant to act on behalf of his company beyond the date of his resignation. Moment he resigned from the company, he is no more an employee of that company. He does not have any right to use the, say, valuable informations of that company to do the communication on behalf of that company. So it is legally wrong. But however, it is precisely what he wanted, he could do when he attempts to establish official business communication with a customer of his company, say June 10th 2019. Now the situation here is that Prashant is left a job on 1st April 2019. On June 10th, he is trying to establish a communication with the customer of X company to which earlier Prashant belongs. So with the details of the certificates what he had, with that he is trying to establish a communication with him. In case if certificate is not revoked, what all the things that will happen, we're going to discuss it now. Based on the expiration date in the Prashant certificate, the customer of X company would deduce that the certificate is valid. It is quite natural because certificate is having a validity date up to December 2020. But Prashant has left the job on 1st April. This is not known to the customer of the company X. So what he will do is, based on the certificate information, he will try to communicate with Prashant. Again, Prashant would be able to authenticate himself or perform, say, unauthorized decryption, since he knows the private key corresponding to that public key in his certificate. Thus, Prashant might continue to do business on behalf of his old company, so even after he resigning. So based on the scenario 1, we need a mechanism to revoke a certificate issued by the organization to an employee when he leaves or changes the roles. Now consider the second situation where, say, the CA1 is issuing signing the certificate of CA3, CA3 in turn signing the certificate of CA6 and the different users that belongs to a CA3. Say, in case if the private key of CA3 is compromised due to some reason, so an attacker with access to the compromised private key could do the followings. Okay, in case if CA3's private key is compromised, the attacker may do these following things. So he may generate the public key private key pair XY, create a certificate containing that public key X with a subject name U, say signing the above certificate using the compromised private key of CA3. Now he is acting as a CA3 and he is issuing a certificate to another user. The attacker has thus created, say, some fictitious entity U. Now the attacker can forge the signature of U on any messages by signing with the private key Y. To handle the above mentioned two scenarios, we need a revocation, premature revocation of, say, certificates that were issued by some. Now we discussed regarding a revocation of premature revocation of certificates. So moment certificates are revoked, there should be a mechanism to convey this revocation to a different parties. So one possible solution for this particular problem of conveying a revocation to a different parties is use online facility that provides an information on current status of digital certificates. For this purpose, a protocol called Online Certificate Status Protocol OCSP is used. Say this nullifies the principal advantage of digital certificates in the first place, that is, say, needed for online public key information facility. The second method of conveying the information of revoked certificate is, say, distribute the list of these revoked certificates, so something known as certificate revocation lists, to different users. The frequency of list updation is an important thing in this, say, solution. If CRLs are distributed too frequently, they could consume considerable bandwidth. On the other hand, if they were distributed infrequently, the information on recently revoked certificate may not reach those who need it in a timely fashion. So we need to balance between these two. So we should have, say, there will be some, say, middle solution in this thing, like not to distribute very frequently, not to distribute, say, very infrequently. So there will be some middle way through which we are the certificate distribution will happen. In both these solutions, the onus is on verifier to make sure that the certificate is currently valid. By contrast, it is possible to design a system wherein a signer requires the cooperation of trusted third parties in generating the signature. Such a scheme is going to be discussed in the next topic. Now, in this third solution, design a system where a signer requires cooperation of trusted third party in generating a signature. Both signer and a trusted parties have a part of private key with neither party knowing the other's part. So both the parties have part of that private key and both are not aware what part the one is holding. So neither acting on their own can create a signature on a document. Such a scheme is proposed by Bond 04. So that particular scheme is proposed by this paper. To sign a document, the signer would contact a trusted third party. Before, say, acquiring to cooperate in signing, before entering into a signing act, the trusted party could check whether the signer certificate has been revoked or not, and if it is not revoked, it will participate in creating the signature. So that means here we are putting a complete onus on a trusted third party which is maintaining a certificate revocation information. The trusted third party may also act as a time-stamping authority and certify the time at which a document is signed. This may be done, for example, by signing the values obtained by concatenating a timestamp with a hash of the document. In the next class, we are going to discuss regarding identity-based encryption. So, Wednesday we are going to discuss regarding this identity-based encryption, and we will also start discussing regarding authentication. Thank you.